Hello everyone, I hope you're doing well from wherever you're watching from, and thank you so much for watching this session. This is part 3 of this series, and in this session we will be demonstrating to you how to configure ISIS on Nokia routing devices in AS65002. So in the last session, we've demonstrated how to configure OSPF in AS65000. And I know you're asking yourself, why are we configuring OSPF? Why are we configuring ISIS when the focus is on BGP? So you need to understand that before we do any BGP configuration, we need to do some prior configurations. We need to do some basic setup. We need to do some basic configurations on these devices so that we can now come and configure configure BGP on top of these basic configurations. So in session 1, we demonstrated how to configure the interface parameters. And then in the last session, we've demonstrated how to configure OSPF as IGP in 65000. So in this session, we are now demonstrating how to configure ISIS in a 65002. Remember, in a 65002, we need to configure iBGP peering session between R4 and R5. And we'll be using the system IP addresses to establish this peering session. So we need to ensure that we have connectivity or we have reachability between the system IPs of these two different nodes, R4 and R5. So this is the reason why we need to configure an IGP ISIS in a 65002. But before we start the configuration or before we start this session, just a kind reminder or a kind request that if you are watching this session and you've watched other sessions on this training platform, kindly support this platform by subscribing to this channel. Also, remember to like, comment, and share this video with your connections. So when we talk about ISIS, ISIS is almost similar to OSPF. They are both link state protocols. They are both interior gateway protocols. So we can configure ISIS on this network so that we can have communication within the same autonomous system number. So that is why we need to configure IGP or ISIS between R4 and R5. ISIS is also a very common protocol. You expect to find it configured on many networks, especially the IPRAN network for service provider, so that we can have end-to-end connectivity between different nodes within the same autonomous system number. So let's look at the configurations. We have the configurations on R4. So you also need to configure an ISIS process. The same way we did for OSPF, you also need to configure an ISIS process. We are configuring ISIS process 10 on these routers. Then you need to configure the router ID. The router ID plays very important role in ISIS. Remember, ISIS has the network entity. The network entity will be generated based on the router ID. So we have the system ID, which is part of the network entity, and that system ID will be generated based on the router ID. So it's always recommended that you need to configure the network, the router ID manually, and you should ensure that the router ID should be unique on all the different nodes within the same ISIS domain. So we configure the router ID to 1.1.1.4, which is the system IP, and then we need to configure the area. Remember, ISIS also supports the concept of areas. So we are segmenting the network into multiple areas. So we are configuring area ID 49.0010, and then you also need to configure the levels. Remember, ISIS supports 3 different levels. We can have level 1, level 1, 2, and level 2. So in this setup, we are just configuring these routers in level 2. So you can either decide, depending on the network requirements, which level will you configure. Is it level 1, level 2, or level 1, 2? So we configure the routers to be in level 2. Once we've done that, we need to activate ISIS on the interfaces. And the same way we activated OSPF on interfaces, we are using the same approach. You need to list these interfaces under ISIS configuration, and then you can configure the interface type. It can be point-to-point, it can be broadcast, and then you also need to enable this interface. So you run the no shutdown command. Finally, we also need the point-to-point interfaces. We need to activate ISIS on them. So we specify it as a point-to-point. You can also configure the metric parameters. Remember, ISIS will define or will decide the optimal path based on the metric. So you need to configure the metric or cost values. You can either do it using the reference bandwidth, or you can manually configure the metric value. So in this example, we are using metric 100 manually configured in level 2. After that, you need to enable the ISIS process using the no shutdown command. So if you don't run this command, the ISIS will not be running. So you need to enable it by using the no shutdown command. Now, there are other parameters that you can configure when you are configuring ISIS on Nokia routing devices, which you can explore when we'll explore when we discuss ISIS implementation on Nokia routing devices. On R5, we do the same. We configure process 10, we configure the router ID, we configure the area ID. Remember, these two will help us to generate the network entity. The router ID will be used to generate the system ID. So we are able to generate the system ID from the system IP address. The level capability is also set to level 2, and then we activate ISIS on the interfaces. So for the metric configuration, it's always best practice that if you configure a cost on the interfaces, you need to keep it uniform. If you configure 100 on one end, it's best practice to configure 100 on the other end. Don't configure 100 and then the other side you are configuring 1000. So let's log into the devices, do the verifications. Remember, in the last session, we already demonstrated that we've checked the interface configurations, we verified them. If I run show router interface, you see that we have these interfaces on this router. We try to ping 20.20.20.0. We are able to ping the point-to-point IP address. But remember, for BGP configuration, we need to be able to ping the system IP address. So if I try to ping 1.1.1.4, you see that we are not able to ping. This is why we need to configure an IGP protocol so that we can allow the connectivity between these two nodes. So let me copy the configurations. Starting with R4. So I'll copy the configurations for R4, log into R4, and I'll exit and run the commands. If I do configure router and do info, you will see that the commands are here. And then I'll do the configurations for R5. So on R5, I'll exit, run the commands. I can do configure router again, then info, so that you are able to see the configuration. So these are the ISIS configuration that we have on this router. And once we've done these configurations, we can now go ahead and do the verification. These are the commands that we can use, starting with show router ISIS adjacency. So we need to check the peering adjacencies between these two devices. So you run show router ISIS, you can give the process, or you can use the all command. Let me first do it using process 10 because we've configured ISIS process 10 adjacency, and you will see that we have one adjacency, which is R4. You can use the detail and see the parameters. You can see the system ID has been generated from the loopback IP or the system IP address. If you know the process, how we generate the system ID from the system IP or the loopback 0 IP address, you can tell us in the comment section. And then you can see the uptime. You see the SNPA, you see the priority, the circuit type is set to L2, max hold, the timers, the adjacency level is level 2. You see the IPv4 neighbor, we haven't configured IPv6. The number of restarts, last restart, it has never restarted. Restart support, the GR, graceful restart, is it enabled or not? You can see all these parameters. Once we've checked this, we can also check the interface. Show router ISIS 10 interface. See that we have these two interfaces that we've activated with ISIS. You can also use the detail command. You see so many parameters. We have operation type point to point, circuit ID is set to 1, admin state is up, level capability. You see other parameters, the authentication type. We don't have an authentication configured, the hello timers, priorities, and many, many other things that you can observe when you run the show router ISIS 10 interface detail command, this command. So you are able to check all the parameters, especially when you are troubleshooting. Many times, of course, you may not use all these commands, but when there is an issue, when the adjacency fails to come up, when some routes are not being learned correctly, then you need to understand these commands so that you are able to use them to troubleshoot network issues. And then we can also check the LSDB. So show router ISIS 10 database should be able to see that we have two LSPs. These are the LSP ID. We have the sequence checksum lifetime attributes. You can use the detail command and you will be able to see other parameters, especially when you are troubleshooting again. We can check the routes. So I run show router ISIS routes. We don't have instance 0. That's why you can either use all command or you can use the process ID. So you see that we have these routes which we've learned through ISIS. I can show router ISIS 10. If you use question mark, you see that we have other parameters that you can check, SPF log, many, many parameters that you can check. You can check the topology, summary address, host name, database capabilities, routes, the prefix seed if you are using segment routing. So there is a lot that you can explore when you are configuring ISIS on different vendors. Then let's check the routing table. So I do show router route table. Let's see whether we have ISIS routes. You see that we are having 1.1.1.4, which is the IP of R4. We are now learning it through ISIS. You can also specify protocol ISIS command, and you will be able to see just those routes that we've learned through ISIS protocol. Finally, we can try to ping. So initially, we were not able to ping the IP address of R4 from R5, but you can see that now we are able to ping R1, and from R4, from R5 to R4, we should be able to ping 1.1.1.5 also from R4. So we have established the connectivity that we need to be able to establish iBGP peering session between R1, between R4 and R5 in a 65002. So this is the reason why we need to configure IGP on this device. These are the commands, very easy to understand. If you have any question about this command, feel free to ask in the comment section and we will be glad to clarify to you. And then these are the verification commands that you need to use. Many of these verification commands will come handy when you are troubleshooting ISIS adjacency or routing issues in your network. So I hope you've understood the ISIS implementation. In the next session, we will now start demonstrating to you how to implement BGP by starting to configure iBGP peering sessions in a 6500 and 65002. So thank you so much for watching this session, and I hope to see you in the next session.